Okay. I made a mistake on Monday when I present this particular diagram. Let me say that my MW, it was when I used test MI, I think. I kind of interpret the result. Wait a minute, not this program. By the way, which one was I was worried about? It must be robot, sorry. Yeah, over here, I think I make the mistake and such that because I ordered the last two arguments somehow in the code, so the printout result should be the format looks like this. Okay, so it will okay, I will check. If you look at the result, let me look at the result again. So confused when I did this on Friday. No, on Monday. If I go to test, let me try to first fix this, then we'll go back to where we are. So I try to print out this one, the address of this 5. So the first number I print out is a robot number. Now I put it here so we can clearly see what's going on. So the robot number, why don't I do this? Really compile this code and run this program. Okay. So if we look at this 5 number, I'm talking about this 5 number, that the first one's robot number. If you take a look at this, what's number 1? Number 1 is here. Number 2 is sequence number. Number 3 is this URL, and number 4 is this. So this is different from what I showed you last time. So it's number 1, and then number 4, and then number 2, and then number 3. Is that right? Did I get it right? Let me look at this again. It's confused every time I talk about this 5. So number 1 was a robot number, and then it was sequence number, and then it was a URL, and then SSN is the last. Okay, so let me go back. So SSN is the last, number 4, number 1, number 3. Okay, so that's the order. Okay, so you're kind of seeing that the difference. I mean, I just want to tell you that this 5 number represent virtual inheritance. This 5 number on the left represent multiple inheritance. So they're basically different, and there is a good reason for them to be different because they need to handle the sharing of a one copy of the core object, which is a share between person and thing, and therefore they need to introduce extra layer vtable in such that they want to arrange a little bit different. So obviously you can do the same thing like what I did here to kind of print out all the result and then see what's going on. All right, so today I'm going to teach you a different way to look at this memory layout. To look at this memory layout to see exactly how the memory are allocated with whatever inheritance hierarchy that you have. So I want to show you a program. This program, I call it, let me do an Emacs and SWVI all in one. Okay, I want to show you this, oh, not this one. I want to show you test VI all in one .cpp. Okay, what is this program? I will explain to you why I have to do it this way in order to print out the layout. But essentially, the inheritance hierarchy is exactly the same as I talk about on Monday. So essentially, I have a class core. And the other thing you might notice, I stopped using stuff like a string. I all use double. for another reason, which I'm not going to tell you right now, but later in the class, if I have time, I will tell you. I'm doing this double, using this double, and then I have this person, which is inheriting with virtual and public from core. And then I have and again, I have SSN, I also converted to be double. Remember, my purpose here just want to print out the memory layout. So I convert pretty much everything to double. And then I have a class thing, which is a virtual public. And the same thing, I have a one number called sequence number. I also made the double. And then finally, I have a class robot, which is a virtual public person, virtual public thing. And then it has a attribute called robot number. And again, it's a double. So essentially, I represent exactly the same inheritance hierarchy like what I show you on Monday, except I change everything to double as the attribute. And then, of course, in the program, the main program is very simple. In fact, I just basically create one single object called my robot from robot, and that's the program. So I have a program that's doing nothing but include all the inheritance relationship, and it's very simple. And the purpose of this program is not trying to do anything, but the purpose of the program is try to see the memory layout of all the classes I included. So let's take a look at the makefile. How do I compile this program? In fact, I didn't actually compile this program. Well, I'm using a different option. So this is the rule, including, you might have seen me doing this, but I want to now explain to you that now this is a line I'm going to compile this program. I'm calling a G++, but with a flag called -CC1. So whenever I said G++ minus CC1, I'm not really using G++. I'm using a different compiler called CLAN. So essentially, G++ and CLAN, they're both G++ compiler, but they're different compiler, but CLAN, you have to include a bunch of different things in order to do that. But with memory location or memory allocation, that CLAN, in fact, provide a really nice facility called dump record layout. So this is, you see that I'm actually turning on the flag called dump record layout. So the purpose of the whole line, you see that I'm actually pointing, this part is essentially saying that, well, I want to use CC1, which is a CLAN instead of using G++. And because of that, I can start using this flag called -F dump record layout. And then there was a bunch of include flag, might or might not be necessary. And then this is the program. And the output of the program is not a .o file, but instead is a memory layout file, which we store in vi all-in-one.txt. Okay, that's just the way I handle this to get the memory layout. Okay, so let's see what we got. Okay, so you can see that the last two line is the two line I show you. So in fact, I have two programs. One is called all-in-one multiple inheritance. One is called all-in-one virtual inheritance. It's just, the difference is just whether I have that keyword virtual as I showed you last time. If you have the virtual, then it is virtual inheritance. But if it doesn't have that virtual, it becomes multiple inheritance. Okay, and then the memory layout is being shown here. Let's first look at the multiple inheritance. Okay, the output will look like this, and it will show the memory layout for every single class. So the first class, the first memory layout it shows is the core. It's a core, which essentially has only one argument, host URL. And remember, in this case, host URL is a double. I convert everything to double, so this has only 8 bytes. So essentially, this object completely only have 8 bytes. That's why you see here is a size of the object is 8 bytes. And then we look at the second object is what is a class person. And remember, this is multiple inheritance. And you can see that the first is still started with 0. By the way, this is called offset of each of the attribute. This is called offset. So from the first byte of the object, what is the how do I say that? The address difference between the beginning of each of the attribute and the first byte. So 0 means that it's actually started at the beginning. So if this is multiple inheritance, when you talk about class person, then essentially it has two parts. One part, this two line, essentially represents the part you inherited in, which is the core. And that core is 8 byte, right? Just like the above, the first part, they're identical. And then starting from the 8th byte is the content that's specifically to person. So now you can see that the person has what is the SSN. I kind of simplify. So it's also a double, it's 8 byte, looks like this. And the total of the person object from here to here, you see that is 16 byte. Why? 8 byte for core and 8 byte for person. Okay, that's the memory layout. So with multiple inheritance, core always, the base class always come first before you start worrying about the derived content. Okay, the same thing with thing. You can see that thing is the same thing, that you have the core over here. This is part of the core because thing also inherit from the core. And then you have your sequence number, and total is 16 byte. Okay, so far we took care of the 3 classes, core, thing, and person. Okay, now let's take a look at the robot, which is the multiple inheritance. Now you see that this is interesting. Okay, because when we do the inheritance, we say class, robot, colon, public, person, and then public, thing. So that's why person will come first. Let me actually take a look at the program again, which should be test. Is that right? Test MI all in one. Yes. If you look at this, we started with person and thing. So this order essentially determines your memory layout order. So in other words, when you come over here to see this, this part, this 3 line, this 4 line, in fact, represent the person. Okay, so you have a robot, and then this part represents the person, but then within the person, core comes first, and then the SSM, the person. So essentially, you're imagining your robot is core, and then the person, and then core, and then you have the thing. That's why the next 4 line represent the thing, also 16 byte. So after you have a person and thing, they're both 16 byte, and then you have the double over here, which is the root. Okay, so essentially over here, I want to say that there was one thing I don't know if you realize is when you do casting, if you gave me a robot object, with multiple inheritance, if you do a casting for a robot object to a person object, the casting shouldn't change any address. Why? Because it should still be the same address. You see, class robot, class person, and class core of the person, these 3 are all at the same address. But when you casting to a thing or the core thing of the person, by the way, your casting should move. The pointer should be here, 16. So multiple inheritance, sometimes when you do casting, you're going to see that the address will change when you do the casting. Okay, and if you take a look at the memory layout, you kind of understand that. Why is that? Because that's how they arrange everything. Okay, let's try to modify the program and see how this works. Okay, let's go back to the let's go yeah, I'll do that later because let me finish the other part. Okay, so that's that's the memory layout for multiple inheritance. It essentially could, this one is robot. Where's my robot.h? This should be consistent to this one. Why you will have, that's interesting. Why this one is a thing first? Let me check. What did I do over here? Oh, you know why? Because I put thing first in this program, and over there I was doing person first. So because the thing is first, so the thing become the first one, and then the core to the, the core to the thing become the first one, and the thing become the second. That this two part represent the thing object. And then number 3 is the core of the person. And then number 4 is the person itself. So number 3, number 4 basically is the person object. And then finally, you got to number 5, which is this one. Let me actually change it. I sometimes feel I make a mistake when I want to make it consistent. Okay. Let me go to test MI all in one. So I want to switch this to, so I will make sure that the other program, this program, that will generate consistent result. Okay, now I can take a look at this one, and the memory layout should come with the right order. So thing comes first, but within thing is the core comes first. Okay, so that's the memory layout. So this is a way that with, by the way, there are multiple ways you can generate this, but different compiler has a different option. And the one that I'm more familiar with is the CT1, which is using -f dump memory layout for, this is specifically designed for the C++ inheritance. Okay. All right. So now I'm going to show you the other one, which is the virtual inheritance, VI. Okay. Now let's first take a look at the core, because core is the ultimate base for the whole tree. So therefore, there's nothing different. So this looks like exactly like that. But now we're looking at the second one is a person. So now you already see the difference, even though it's just adding a virtual, even though it's still single inheritance between person and the core. They're essentially just a single inheritance relationship. But even the single inheritance, but when you have a virtual keyword, it's already have a vtable pointer. So it started with a vtable pointer, and then with the only SSM, which is the double, and then it include the core. So essentially it flipped. Have you noticed that this, even this single inheritance, very simple, the relative position about the class core and the attribute already flipped. Okay? So you have this. So essentially, in general, for you to assess this particular part of variable, it really depending on what's the content that's in the vtable you set up. Okay, later we'll see that why is you cannot easily say, hey, that one is actually the core. You can directly, in some cases, yes, the compiler will know, but in a lot of cases, compiler has to define, has to wait until what's going on with the rest of the code. And this is the same thing for thing. You can see that in the thing, it also flipped. So whenever you have a virtual, the first 8 bytes is always the vtable pointer pointing to the vtable, so they can actually handle things differently. All right, so now we'll have to look at the last part, which is the robot. And the robot, you can see that the first one, of course, is still vtable pointer. You still have a vtable pointer, but then the first things that come is the robot itself. the content of the robot. That's why it's the robot number is the first one. Remember, this is opposite about multiple inheritance. That virtual inheritance, you put yourself right after the vtable pointer. I mean, this is, by the way, this is always consistent. If you think about this, the thing is always the vtable pointer and then your own attribute. And the same thing happened to person as well. So it's always vtable pointer and then to the attribute that to that particular class we try to address. Okay, so after you're done with that, then this part is really depending on the situation. So you can see that the next one I have is the class core. Okay, so basically is the vtable pointer, the content about the robot, and then I'm actually having this core. Okay, so now this is different from this part because if I look at the thing object, it's a vtable, sequence number, and the core. But over here, let's take a look at what's the thing object over here. The thing object starting over here is a thing object, and then thing vtable pointer sequence. These three lines are the same. But after that, it doesn't have the core. Because why? Because all this pointer is depending on the vtable pointer over here that they will provide a pointer to this core. So essentially, this is not determined at the compiler time regarding where you can access that, that core, which is shared by three different classes. One is class thing, one is class person, and one is class core. Okay, so it's not that important, to be honest with you, for you to understand or to even to remember exactly how is the memory layout for each of the object. That is, in fact, you always have a way to find out. You either using the tool I provide or just print out a few addresses that you can do. And essentially, the most important lesson I want to convey over here is that when you have a virtual inheritance, the memory allocation is not contiguous and it has hole, and each of the hole will include a vtable pointer. So a typical, if you want to do some kind of memory copy of the whole chunk about the memory, and you will see that that might not work for this kind of object because their the relative location is unpredictable if you want to do a bulk copy of the object from one location to the other. Okay, but the second question, the second main point I want to convey to you is that the difference between virtual inheritance and multiple inheritance is not only semantically that you need to do somewhat differently, especially you want to access the common ancestor core in the virtual inheritance. And not only that, but you have to be aware that the memory allocation, they're totally different depending on your multiple inheritance and virtual inheritance. Okay, all right. So it's just this is the something you should know. That's the complexity about a layer that's under the surface of the language. Later, if you want to be a developer for a system program, such as like a compiler, such as memory management, such as operating system, then yes, this kind of things is important. But until you hit that level, I think it's enough for you to just understand there's a difference there. Okay. Any question? All right, good. So I'm going to move to the next topic. I'm going to start talking about exception. Okay, so first, what is an exception? You probably saw me doing this. Let me show you an example. I call it trouble test. Okay, you probably show me doing this. I have a try and catch clause. So let me say that. I have usually the syntax is I will start it with try, And over here, there's a sum code. And then after the pair of curly bracket, I'm going to say catch. And within the catch, it's the syntax of catch is almost like a function. And within this, the pair of parentheses is some kind of parameter, is really just one parameter. Basically showing that what kind of things you're catching. And then after that, you have another curly bracket, and you're going to put some other code over here. Okay, you have syntactically, you have this structure. This is called try clause and then catch clause. So try clause is defining, okay, in between this pair of curly bracket, those are the codes I want to apply exceptional handling, meaning that if there's some kind of situation or error that occur within this block of code, then I want this code to exit immediately and transfer the control to the second part of the code, which is the catch. So you think about try is something, it will not let it continue to fail, but instead it will stop and release its control to let the catch to be able to continue this to handle this particular condition within this piece of the second piece of code. I should probably say this is a second piece of code. Okay, second piece of code. So that's essentially exceptional handling. Is catch something, sorry, try something, and then generate some kind of error and then go in there. Okay, there's another keywords. So whatever you will generate, that sometimes you have to, how do I say that? You have to produce some signal such that the catch code will be able to catch. So that is a keyword, another keyword called throw. So within the try clause, you will see a throw clause, a throw statement, which basically that statement will trigger the transfer of control from the try block to the catch block. So this is kind of like high level about how exceptional handling work. Okay, so I'm going to show you a sequence of example. Hopefully through this example, you kind of understand whatever I was saying better in the programming sense. Okay, so over here, I'm going to show you this piece of code. You can see that this piece of code right now have a try. Okay, this part is the try clause. I would say that this part, I'm trying to guard it. And then over here is a catch. Over here, I say, hey, I have exceptions. You can see that the catch over here is not doing anything, but just print out error message saying that, hey, you're having an exception. I'm just print out this message and acknowledge that. But over here, I have a throw that this statement, I'm going to produce something. So okay, so one thing I should say is when you have a throw, the things right after the keyword throw is always an object or a simple type. The object could be a simple type such as an integer or is some kind of object. Okay, so over here you see that this example, let me actually try to do this. I can say, okay, I will show you the simple example later. But here you can see that I'm actually throw a class I declare called trouble. And then it has this another curly bracket. Does this remind you anything? This is what we call bracket initialization. In fact, the whole thing, throw, trouble, that parenthesis I just marked is essentially creating an object called trouble. And the same thing with this line. This line basically also, if you look at this, is throwing something, and then with that bracket initialization basically has one single argument, and nobody on Piazza knows the trouble I have experienced. Okay, so let's take a look at the definition for trouble. So trouble is a class. Okay, think about this. This is my trouble. It's very simple way of defining an exceptional object. Exception object, sorry. You can see that I just declare a class trouble, and then the trouble has one argument is called message. And then I have a one parameter, I have a one constructor and one member function. So the member function is called what? And then the constructor basically take one string output saying that, well, if you want to initialize the member called message, you either initialize as the string you input, or if you didn't have any input, then the default is, this is the default ecs36b trouble. Okay, so this is the syntax for you to be able to specify a constructor with a default value for that particular argument. Okay, let me try to parse. This is a little bit, just 1 second. So this is the constructor declaration. This is the part you expect the constructor to take the argument, but with a default argument. You can use it for exception or any object. You can do it this way. And then this after colon is essentially your the assignment or initialization for your private member. So you can say message initialize as str. Where's the str? Str is here. And then after that is the body of the constructor trouble, which is nothing. Okay, so I'm basically doing this. Yes. Yeah, you can have multiple throws. Like one start getting up and you say like your path is like you go or you're not even separated. So yeah, what you can do is that you can throw the first time they misspell the password, right? And it will catch by some other piece of code. And within that catch, you can try to check the password again. And then it might generate another throw to another catch clause. So you might have a 3-layer of the throw and catch. And eventually you generate some error you really want to generate, say, such as you fail to do that 3 times. Okay, but one thing I would say exception we always avoid is some kind of recursive. You don't want to kind of go out and try to go in, and you might form like an infinite loop if you're not careful. So just, I'm not saying you cannot do that, but it's hard to manage. Okay. All right, so this is a trouble. What is a trouble? Trouble is just a class, just like any other class. Usually it has one attribute called message. Usually it has a one method called what. What means that what is the error message we try to catch. Okay, so now if we understand this part, let's try to come over here to see the simple program example. So the example basically say, hey, I have a loop of 2 iterations. So this is essentially a loop of 2 iterations. The value of I should be either 0 or 1. So essentially say when I is equal to 0, I'm actually just throw trouble without any input argument. That means it's going to print the default string. And then if you do trouble the second time, if I is equal to 1, then it will say, hey, nobody on Piazza knows the trouble I have experienced. Okay, so then you could suppose if you execute the program, is actually going to come out here to because why? You generate throw a trouble object And then I basically catch of the same object. I'm using reference. I'm not using object because I want to maintain the content of that object. And then when you come over here, when you do the catch, then within here, I'm going to call that function called what. Basically print out that message. If you remember what is a what. So here is a what. What is just return the message, okay? And then you print the message over here. Okay, you print the t dot what is the message we generate. Okay, so let's try to compile this. Compiling trouble test .cpp, and I'm running it. You see, that's what I'm getting. The first one, I'm getting, this is a default ecs36 trouble. And the second one, which is 1, is nobody on Piazza knows the trouble I've experienced. Okay, so that's the simplest case. So I want to show back to you what's going on, and then we'll be looking at something more complicated. Okay, this is a program, this is a syntax. Remember, you have to put a try clause. Within the try clause, you have some throw, and then you try to do catch, and then sometime you have another piece of code to handle that. Okay, I do want to say that sometimes you don't have to use to generate the exception. Sometimes you don't have to throw inside this curly bracket. Sometimes you could have done this. Let me actually do this way. I can define a function called void, and I call it void foo, okay? And then I can say within the void foo, I will say, I can say throw, trouble. I can do this. So what I'm going to do is, instead of saying throw, I would just say foo. I just call foo this way. So therefore, if I compile this code again, I should expect to generate exactly the same result. Why is that? Because the reason I'm showing you this example is that sometimes I have a try clause. The throw statement might not be at the first level. It might be embedded somewhere in the function you call. As long as any of the function you call generate that throw, you're going to see that throw, and then you're going to provide a catch clause to do that. So why is this? For example, you decide to use somebody else's code in object-oriented. This is very popular option. You basically include some of the code from JSON CPP library, or you actually include code from the system library. And the thing is that each of the library, they might generate some kind of exception. And therefore, even though your code didn't have any throw statement, but the code you reuse or share from somebody else might actually generate a throw. So you can actually write a code to catch that. So now let me do this. Let me try to change this. I will do this foo. Let me change this. This will be fun. I would say this is a character star arrow message. Okay, I'm going to print out something. So I will say this is a foo, and I'm going to say this is well, let me see, default I is equal to 0. And this one, I'm going to change the code to be foo. So you see that I'm actually writing the code. Looks like this. And I would just say trouble, arrow, MSG. Let me see if this will compile. Yeah, I know I'm going to get some warning, but I'm going to do this. It probably generated a warning. It's probably okay. I'm just running it. Yeah, it's okay. It's just a warning. It helped me to automatically convert. So you can see that I actually in my code, I didn't have any throw statement, but this two function, the foo, is actually producing the statement I need. Okay, so let's actually go back to here. Let me just make sure. Okay, so you can see that this particular function main, I don't have any foo. Okay, and then I have this function code over here. Okay, so let's do something a little bit different here. Is that assuming I didn't have the catch. I say catch instead of trouble, I say catch an integer. And then over here, I just say exception and \n here. So essentially, I'm trying to catch an integer, but the throw is going to throw a trouble object. Let's see what will happen if you do this. Okay, now you see what happened. Is that if you write the code, you see this message. It's saying that, well, it's the program terminate because an uncaught exception of type trouble. If you see this avoid trap 6, that means what? That means your program or the program you're using, in this case, is a foo. I'm actually using somebody else's code as a foo. It will generate an exception of the type trouble. But in my program, I'm trying to catch a different thing, or I didn't even catch anything at all. I'm just having that, it generate this. So meaning that is having some code, but is not being caught, then you will see this error. So in other words, we have to be careful when you write a program in C++ and you want to include some of the library from other part of the world. And if that particular code has any kind of exception that's actually generated and you didn't catch it, then you're going to get this. So your code will break. Is going to, so we have to be careful. So at this moment, I just want, do you have any question? 7 of you? It's great. Today, you all have opportunity to work very hard. Okay, so how should we do that? I mean, if I say you're going to have this trouble, not trouble, this kind of error, you need to, do you feel a lot of burden that now from now on, if you want to write the C++ code, and you're going to include a lot of things that define or linking the library from others, now you feel panic. Wow, I have to make sure I catch everything that potentially can throw, otherwise my code will break, right? So that's the issue. So the way to solve this is that we want to come up with some kind of standardized exception. We call it exception, by the way. It's a standardized exception. In fact, we call it STD exception. And then every single program that I'm include, if they want to generate any kind of exception, they have to derive from the standard exception. So you see, we apply the concept of inheritance. So essentially, if you want to introduce a class called trouble, this trouble need to derive inheriting from the system standard exception. If you do this, then essentially I just need to write a code say catch the general, the parent or whatever, the base class exception, then essentially I can catch any kind of exception. Okay, so that is the trick I'm going to show you. So let's take a look at another piece of code. Now let's take a look at this code called bat alloc test. I mean, before I show you the whole code, I want to show you the first thing I have is what? Is catch exception ME. And exception ME is essentially STD exception. Okay, these two are the same. All right, so let me, I kind of hide something. If you go to ecs36b common, probably shouldn't do this before I teach you exceptional handling. But let's take a look at this. If you come over here, ecs36b common, and down here, where's the exception? I thought it's, oh, here. You see that I'm using this include exception. So this is basically the standard exception, which is the root of the whole hierarchy for all kinds of exception you might have. JSON CPP has an exception, it's a derived class from this exception as well. Okay, so pretty much everything JSON or whatever library, they must derive from this standard exception. All right, so okay, now let's try to run this program before I tell you what this program is doing. So I'm going to compile this program called the bat.alloc test.cpp. Okay, I create this one and then I basically run the program. 400, it doesn't generate any exception. If I say 400 like this, now you see that have an exception. So the difference is that over here, I'm not triggering the exception because the input argument is very small. But when I actually input a huge number, it says it actually jumped into the exception and saying that this exception is a standard exception, and then it basically catch a error condition called STD bat.alloc. Means that essentially saying that, hey, the system doesn't have enough memory to deal with the request because you're requesting a huge amount of memory. I cannot handle that. So the condition of that exception is called bat.alloc. Okay, and the standard exception. Okay, so let's now take a look at the code itself. I have 2 minutes before you can enjoy your Thanksgiving holiday. So look at here what I did. I have a try clause. Inside here, I did a new of a long int based on the size, M size. And what's the M size? I actually got M size from the argument of the program. And that's why when I add a small number, like a few 400, it's no problem. I can allocate create this large array of long integer, no problem. But when I add that argv1 to be a huge value, then this two statements are going to generate a bad allocation error, and then it will basically catch. You see that here, I didn't have any throw statement. I just have a try clause, and then over here, I just say a standard exception E. That's good enough. Okay. All right. So I'm going to show you another piece of code before Okay, so over here, I include another class called ecs36b exception.h. So take a look, what is the ecs36b exception? So ecs36b exception is down here. Come on, okay. You see that I'm having a class ecs36b exception is derived from public standard exception. Oh, by the way, I did something really horrible. Why is this? I'm using multiple inheritance, and it's not necessary. I'm just using this to tease you a little bit. But this is ecs36b exception is essentially derived from STD. Okay, so if you know that, now let's take a look at what the code I'm doing. So the code I'm doing is here. I throw the ecs36b exception over here. Okay, what this code is doing is that if your array is small, then this one will not trigger the standard exception. I should be triggering this one because this one generates ecs36b exception. And then what I have, you see, I have a two catch clause. The first catch clause is ecs36b exception. And the second catch clause is a standard exception. So depending on what you have, you can have a multiple different exception at different condition of the program, and they better under the same base class as a standard exception. By the way, over here, if I don't have this ecs36b exception part, it will be automatically go up, casting up, and catch by this. Okay, so let's see what this program is doing. The test 2. If I do this 400, which is a small, then it should go to the ecs36b exception. If I go again, I did this huge one, it will go to the bad error. Okay, standard exception. Okay, so this is my first introduction about exception. You can see that it's a convenient way of using inheritance to be able to handle the error or handle unexpected situation within your own code or within you're using somebody else's code. Okay, I feel in my situation is usually try to use other people's code, but I actually provide the wrong argument. And then it usually throw exception at me. I have to basically do using this to debug at runtime. Okay, not just debug, but also handle those situations more friendly. Okay, so I'm going to be finished here. Any question before I turn it off? Okay, yes, Ian. Oh, yeah, I will do that. I will upload. Thank you. Any other question? All right.